Let's return to fundamentals to try to understand Plato a little bit better. Plato and his theory of the forms originates from his two great predecessors. One of them was Parmenides and the other Heraclitus. Parmenides has, in his vision from the goddess, has a static world, a world that is a unity that can't be broken up into parts. And it's from this unity that Parmenides derives his idea about reason. But it's essentially an immobile world, as was emphasized later then by Zeno. Heraclitus is really diametrically opposite. For Heraclitus, everything is change, everything is flux. There is no immobility, the exact opposite of Parmenides. And so in that world of flux, there is nothing that can be hung on to as a thing that is in common from one time to another. In a sense, it means that there can't be a form. So on one hand, you have Heraclitus emphasizing the idea that everything is change, everything is flux. And on the other hand, you have Parmenides, in which there is no change, no flux. Everything is static, but a unity. Both of these are incompatible alternatives. They're both equally unrealistic. And what Plato is trying to do is to form a more realistic unity from these two opposing parts. And that's what the forms are for. Because for Plato, the forms of things allow one to reason, as Parmenides insisted, but the obstacle in Parmenides is the inability to break these things up. Plato sees that there has to be a world that is broken up into kinds of things. And with those kinds of things, one can begin to think and one can begin to reason. For Plato, reason was paramount, and it could only exist if there were a world of intelligibles, like Parmenides, but intelligibles that could be broken up into intelligible parts, which are the forms. And these things allow one to reason. Reason was the primary thing that Plato wanted to allow for. Change as well, and reasoning is a form of change, it's a form of process of argument. Reason must have things on which it can operate. Now, Plato doesn't really give an argument for this, so let me endeavour to give an argument for it here. Let's imagine that there were a world that is more in the way that Heraclitus describes. So it's a world of continual change. There are no forms, there are no kinds, because everything is continually mutable. So there isn't one thing which is the same over time. There aren't many things which can be grouped together as of the same kind. What would that world be? What would a world without forms be? Well, it would be a world in which you could apply to particular things proper names, like John, Fred, Mary, etc., but also to the objects of the world. You would have to apply a proper name to each of them. Everything would have to be given a proper name. Under that circumstance, think of it this way. Suppose you were to try to think, what is an argument? An argument has premises and conclusion. Take, for example, this argument. This is not in the Heraclitean form. Think of what we would normally think of as an argument. All horses are mammals, first premise. Second premise, palominos are horses. Conclusion, therefore palominos are mammals. Well, for that argument, what you need are kinds, palominos, horses, and mammals. If all you have are proper names, the only way you can refer in the Heraclitean view is by using proper names, then all of that argument cannot be formulated because you would not have the same things appearing in the different premises leading to the conclusion. Everything would be different in these. Different because you're referring in separate sentences to things. You can't refer to palominos. You can refer to a particular palomino. You can't refer to horses in general. You can only refer to a particular horse. You point to a palomino, call it Neddy, then Neddy is also a horse. It's also a mammal. The argument can't be got going. If all you've got are the names, you cannot repeat those names in the premises to give you a structured argument that is going to lead to a conclusion. Arguments require the forms. I'll say it again, because this is a dramatic conclusion for most people. Most people have, and as I said before, have wanted to kind of poo-poo Plato's forms. Oh, we've gotten beyond that now. No, we haven't. We haven't. Forms are required for reasoning because proper names, which is all the Heraclitean is really entitled to, proper names cannot function in the way that we require for premises and arguments and conclusions, premises and conclusions in arguments to fit together. The forms of some kind are necessary for argument. That is why, as I said earlier, it's probably the case that no one has ever seriously thought that you could really do without universals. They may have had different accounts of universals. They may have tried to explain them in different ways, but you can't, in any serious way, do without all of them. You could certainly do without many of them. There are many things that Plato probably wants to consider as universals that can't seriously be considered as universals. But nevertheless, we can't do without all of them. Even in sort of modern fundamental physics, you can't do without the concept of an electron. You can do without a concept of this and that electron. You can say that electrons are indistinguishable, but you can't do without the concept of electron full stop. So we still require some forms there, as much as Plato required them in his day, where he tried to make too many things into universals and tried to pretend that these were static forms. That's incredibly unlikely. As I've said before, and as even Plato says, there's no form of dirt and hair. Plato says that seems absurd. And there's probably no form of human being, although Plato doesn't say that. So the doctrine of forms has its underpinning for Plato, as it should for us, the idea that they are required for our reasoning about the world. And I should mention parenthetically that Nietzsche, who I've mentioned before as a disciple of Heraclitus, Nietzsche buys the conclusion that Plato is unthinkable for Plato. Nietzsche buys the conclusion that on the Heraclitean view, reasoning is strictly impossible. Logic is impossible. That is Nietzsche's view. He says it in The Gay Science. He says it in Twilight of the Idols. it's one of his main views. It's an anti-logical view. But if we don't want to accept that conclusion, if we want to accept that there is reasoning and then there is logic, then we need something on which it can be based. For Plato, that was the forms. But Plato, as I said earlier, does have a significant problem in his theory of the forms in the middle period up to the Republic. What we had was an account of the forms, an account of them being eternal, as always, as accessible to us as giving rise to reasoning. All of that's there. But the one thing that's missing, and missing most severely, is what are these forms instantiated in? What is the world about us, the world that we can see, since presumably in some sense, even though we can grasp the forms, we can't see them in an obvious way. That's why, very plausibly, the beautiful can't be beautiful. It would only be beautiful if it could be seen, and it's not obvious that it could be seen. But if we think of these as intelligibles, if we think of these as having an existence which is eternal, then that eternality is not compatible with a world of change. So one thing Plato wants, in concession to Heraclitus, is to have a world of change. And how is that compatible with the world of immobile and eternal forms? Well, Plato's big theory on this comes out in his subsequent, later philosophy, his philosophy that includes the Timaeus. We've had his own arguments for rejecting his middle period Platonism, and that is explained and expressed very, very well, devastatingly well, in the dialogue called the Parmenides. The Parmenides is, in a sense, a Parmenidean attack on the middle period forms. But there is also the possibility of, as I've been saying, of adjusting the whole theory of forms to be compatible with a more Heraclitean view, a world that does have change. And this is what you get in the Timaeus. Now, the Timaeus is a very interesting dialogue, and it's one of the dialogues that existed in the Western world. Almost all of the dialogues, except the Timaeus, were lost in the Western world for thousands of years. The Timaeus was not lost. It had been translated by Cicero in the Latin period, and that translation by Cicero continued on, and so was continually reprinted and continually existed in the Western world. But most of Plato, apart from the Timaeus, was gone. The only thing they knew of Plato was the Timaeus. So it shaped the Western tradition far more than the other dialogues could have done, which only reached the West through Arabic translations in the medieval period, in the later or middle medieval period, from around about 1100, 1200 onwards. That is when you began to get more of a Platonic view, and that was then revived and examined again in the Renaissance. The Renaissance is, in a sense, the rebirth through the rediscovery of Platonic philosophy, which means, in a sense, also the rebirth of mathematical philosophy, which had a limited currency in the medieval period, but certainly not to the extent that the Renaissance required. So the Timaeus was a really important dialogue. What was its main goal? Well, as I've said before, Plato does not give up. Many people have interpreted the Parmenides as Plato giving up the theory of forms. He doesn't. He carries them on, but they have to be adjusted to how they're going to function, how they're going to be realized in the world to give us the world about us. And what Plato invents here is, in a sense, a theory of chemistry. But he doesn't invent it from nothing. He is taking over a vast amount of material from the Pythagoreans again. His new theory is more thoroughly going Pythagorean than even the work of the Republic was. And that's what we get in the Timaeus, a thoroughly Pythagoreanized worldview. This worldview takes as its fundamental constituents, its three-dimensional constituents, the 5 regular solids that are now called Platonic forms. Here they are. These are the cube, the tetrahedron, the icosahedron, the octahedron, and the dodecahedron. Those are the 5 Platonic solids. There are only 5 of them. Now, we call these the Platonic solids because of the way they appear in the Timaeus. Because in the Timaeus they are used by Plato as these basic fundamental elements, or fundamental compounds, if you like. But Plato did not originate them. They were originated by the Pythagoreans. Indeed, it was one of their fundamental discoveries that there were these 5 and only 5 Platonic solids. These were worked out by the Pythagoreans quite early on, and it goes with their geometrized view of the world. In Aristotle, you get the canard that the Pythagoreans thought everything was number. That's absurd. The Pythagoreans were centered primarily on geometry. If they thought anything about numbers, it was that numbers were also geometry. Numbers were represented in geometry. Geometry was the important thing. And geometry was the important thing for Plato as well. It's said that Plato had a sign over the doorway to the academy: "Let no one ignorant of geometry enter here. Let no one ignorant of geometry enter here." And so Plato takes on that geometrical view. Again, to repeat it, because Aristotle's view is repeated endlessly by people who want to denigrate the Pythagoreans, as he did, to say that everything was number. No, it's not true. Everything is really geometry. And that is a very modern view. There are many modern philosophers, more like mathematicians really, but many who have said the same thing. Geometry is the fundamental building blocks of the world. Geometry is the heart of how maths connects to the world, and that connection is crucially important. So how do the Platonic solids, how do they function? Well, Plato, or the Pythagoreans, we don't know who, noticed that of 3 of them, their faces are made up of triangles. The faces are made up of triangles. And a 4th one, the square, it has square faces. Those square faces can be regarded as made up of 2 triangles put together. 2 right-angled triangles of sides, if we want to imagine they have sides 1, 1, of hypotenuse square root 2. So what Plato is doing here, as also the Pythagoreans had done before him, is bringing together the idea of commensurable and incommensurable magnitudes, the idea that the square root of 2 is an incommensurable magnitude with 1, with a rational number. That idea, and probably also square root 3, which Plato also knew was irrational, possibly also square root 5, which is irrational as well. Possibly he knew that, we don't quite know how much of Theaetetus and his discoveries he had absorbed properly at this point, but let's suppose that he had. Then he knew that square root 2 and square root 3 were irrational. And with that, what the triangles are doing, what these 4 Platonic solids that have triangular faces, or in the case of the cube, of faces that can be made of 2 triangles, is we are having things that can be fitted together into this idea that the world is composed of limited, which is rational, and unlimited, which is irrational, magnitudes, fitting together in triangles. And remember, there is no 2-dimensional closed form which is less than a triangle. The triangle is the lowest form that you can have in a 2-dimensional plane, which gives you a closed figure. If you only have 2 sides, then you can't put them together to make a closed figure. It's open. So triangles are the first closed figures. And the interesting thing about triangles is that there are different types of triangles. With a square, there is only one type of square. But with triangles, you've got equilateral triangles, you've got scalene triangles, and you've got, what's that other one? Scalene and isosceles. So you've got those 3 types of triangles, and then within these triangles, you've got also special types of triangles which are right-angled. No equilateral triangle, of course, can be right-angled, but of the other 2, you could have right-angled triangles. It makes triangles interesting. It makes them varied. There are various kinds, whereas there is not one kind of, there's not more than one kind of square. You could say also there's not more than one kind of sphere. A sphere, a circle, apart from its radius, which makes a difference, it's not different in kind. Triangles are interesting. That's why they were attractive to Plato. They could be fitted together. So we've got this idea that there are 5 Platonic solids. 4 of them can be regarded as made up of either triangular faces or of faces that can be made of 2 triangles put together. That's the cube. That leaves one form, one Platonic solid, which is left out. That's the dodecahedron. The dodecahedron has pentagons for faces. It's an odd one. It has pentagons for faces, and they all fit together to make dodecahedron. Now, we have also the idea inherent in Greek philosophy and inherited from Empedocles and a number of others, that there are 4 elements: fire, earth, air, water. 4 elements, and we've got 4 Platonic solids that are made of, say, triangular faces. Okay? Now, we line them up. Cubes align with earth. Why that should be so is an interesting question, but that's what Plato says. Cubes are aligned with earth. And let's say we've got the tetrahedron, the 3-sided pyramid, that's aligned with fire, and the other 2 get aligned with water and air. Now, This is used by the triangles are made up of make up these Platonic solids. So these two-dimensional triangles are put together to make three-dimensional Platonic solids. Those Platonic solids become those basic four elements. They're made up of components, which are two-dimensional surfaces, which sort of come together in space and fit together, perhaps out of some kind of intrinsic idea of fitting together in terms of scale, fit together to make these the surfaces which then make up the elements. So the elements are more like molecules rather than fundamental elements, and the elements are really more like these triangles. Now, what we get from this whole idea of chemistry is a world which is made up of mathematically described entities. It's not said, what are the triangles made of? Plato doesn't say anything about that. And that's another accusation, a charge, a problem that can be put to Plato's view. Though Plato does talk about the fundamental elements as triangles, there is nothing that we can really say about what those triangles are made of. Some kind of space, perhaps? It's not clear. Whether they can't be made of a different kind of matter if that matter itself has to be composed of stuff. So it's not clear that there is an answer to this question within Plato, and not clear how it could be. But once we get these elements coming together, then we can see how certain forms of the forms of how things fit together to make things, how these Platonic solids can fit together, how these can instantiate then certain forms. Forms come back into the picture as the objects that these Platonic solids are made up from, triangles, which use the fundamental Pythagorean building blocks of the limited and the unlimited, the commensurable magnitudes and the incommensurable magnitudes, and the idea that these are forming together in terms of proportions, which are the harmonies. These harmonies are then gathered together to make forms in our world. That is the fundamental idea of the Timaeus. It's an interesting view. By the way, Timaeus, the character in the Timaeus, unlike the earlier dialogues where Socrates is the one teaching things to others by showing them their ignorance and showing them what they don't understand and leading them to their conclusions, Socrates plays very much a minor role in the Timaeus. Most of the dialogue is given up to Timaeus himself, who is expressing this view. He is from Locri, which is in southern Italy. It completes the story. Plato's later view is a thoroughly Pythagorean view. It is expressed in terms of its cosmogony in the Timaeus. It gives us a way of reconciling the elements that were fundamental to Plato, the idea of measure and incommensurability and incommensurability, of measure, of proportion, geometric mean, arithmetic mean, how these proportions relate to one another, how they are founded on the theory of measure, how we get the idea of proportion out of that, which had always been fundamental to Plato's view. It's often not given enough weight, but it's there in the Republic. So proportion and proportionality, and the idea of the forms as static elements which allow us to think and reason about the world, and how these static elements can ultimately be founded on the fundamental forms of, well, the Platonic forms, the Platonic solids, of which there are only 5. What did Plato make then of the 5th, the dodecahedron? Well, the dodecahedron becomes, and this infuses later medieval mysticism, the dodecahedron becomes the shape of the universe as a whole. It's enclosed within a dodecahedron. But sometimes that's the view. Sometimes the later view is that the form of the universe can only be a sphere. Spheres are perfect. No corners. They are perfect because every point on the circumference is an equal distance from the radius. Every point is the same. So the sphere becomes this sort of perfect geometrical entity. And all of the 5 Platonic solids can be inscribed within a sphere. All of the Platonic solids can be inscribed within a sphere. So what we have is, including the dodecahedron, by the way, which was also proven by the Pythagoreans. This gives one the sense of the universe that Plato is now reaching for. He's acknowledged that there was a deficiency and even mistakes made in his middle period Platonism, where we had the paradigmatic view of forms in the good and in the beautiful and the just, whereas these paradigms were realized in this sort of abstract realm and only partially realized in the world about us. What we come to now is not a relinquishing of that view, but trying to give the idea of instantiation of the way in which, in the middle period, you would have things of this world imitating the form. Things that are beautiful, for example, imitate the paradigmatic beautiful. The things that are good imitate the paradigmatic good. Now we have things of this world subject to change because the elements can transform into one another by having the triangles broken up and fitting together in different ways. How that is going to work in detail is not at all clear, I must say. But that's the rough idea, that these triangles can come together in different ways to make up these Platonic solids, and that gives us a world that can be reconciled with a flux, a change in the world. And the creator of the world, because the creator is understood to be one who is trying to make a mathematical order out of perhaps an initial chaos or an initial non-order, let's say, not to put it extremely, to make out an ordered world, puts that order into the world in the form of mathematical entities, triangles, which are then fitted together to make the Platonic solids. Now, what one has to say about this view is that it is, in 2400 BC, thereabouts, it is a remarkable view. It is a remarkable view for a philosopher to have originated. I'm not saying it's true. I wouldn't say anyone thinks that it's true, but it's a remarkable view. And as I say, the fact that the Timaeus was the only work of Plato's known in the long medieval period from, let's say, the Roman period onwards, the only thing known to the West, made it really quite a crucial work and was fundamental to the Neoplatonists of the later Roman period. One can say, probably without exaggeration, that the two fundamental pillars of the Western world were Plato's Timaeus and Euclid's Elements, which were written probably after Plato's death, really must have been after Plato's death, probably in Plato's Academy, and then carried by Euclid to Alexandria, where he taught and where our copies of the Elements have been found. So Euclid may well have opened up a small school for his mathematical knowledge in Alexandria, having taken it there from the much more conducive atmosphere of Plato's Academy and where he had developed it. But probably under the successors to Plato, there may not have been quite the same interest in mathematics that Plato had, and that may also have been something that affected Euclid's decision to move to Alexandria to teach there. And Alexandria may well have been, since it was a Greek world, may well have seemed like a more conducive atmosphere at that point in time. Indeed, we have every reason to believe that it was, for many years afterwards, a more conducive atmosphere to the teaching of mathematics. In some ways, we can imagine that the Platonic Academy was diminished in stature on the death of Plato, and that it continued on in its sort of more a sort of diaspora form into Alexandria, where there was less interference from perhaps the Romans than elsewhere, further from their reach. These things are matters of speculation, but what we have is really a sort of vision of Plato's Timaeus and the Euclid's Elements surviving and giving rise through the Neoplatonic tradition into the medieval tradition, which then gave rise to the all-important Renaissance, which was the bringing of all of these things back into fruition, into the fore of everyone's thoughts, so that the discoveries, the great discoveries of the ancient world could be re-understood and knowledge progress from there, as it did. The Copernican revolution, where Copernicus was meant to be the discovery of the idea that the planets revolved around the sun, which we all learn in school, was in fact discovered by the Pythagoreans 600 BC. The rediscovery of the world was a discovery primarily of the world of the Pythagoreans, which had been strongly filtered through Plato. That was the mainstay of the of the medieval and later Renaissance view of the world. and that created the scientific revolution. Newton was influenced strongly by it, indeed gave answers to certain fundamental questions about the origin of the force of gravity, which were thoroughly Pythagorean. Copernicus, Galileo. Galileo said, the language of nature is mathematics, or to put it more accurately, nature is written in the language of mathematics. It's a thoroughly Pythagorean statement, but a statement that he could have gotten from Plato just as easily. That is the great world of Plato. It continues in his Philebus and in his laws, which repeat these elements in ways which are fundamental and which emphasize these elements as I've been emphasizing them. The idea of proportion, of commensurability and irrationality of certain numbers, non-perfect squares. Those non-perfect squares have their square roots as irrational numbers for us. For them, they were incommensurable magnitudes. They were matters of geometry, not of number theory. So these are what we have as the inheritance in the Western tradition. They were inherited also, one has to say, in the Islamic tradition, since the Islamic tradition had these texts and were able to learn from it. And the Islamic tradition was able to do things earlier within these matters than the Western tradition, which had to wait for these more texts to become available for them to understand more and better about the Platonic world. But the seeds were there. Seeds were there in the Islamic world. The seeds were there in limited form in the Western world. That is what the Western tradition and the Western tradition of philosophy is. I've argued in this lecture that the forms are required for reasoning, that reasoning cannot make do with a language which is stripped of the forms, that in order to have repeated terms in a syllogistic argument or in a general propositional argument, one needs universals, one needs properties which will carry across. And if one doesn't have them, then logic will be severely, well, not crippled, it will be non-existent. That should give some pause for people listening to this who think that I was going to go to the conclusion that the forms are silly. They are not silly. They may be wrong, they may not be quite what Plato thought, but the idea of them is not silly. It is fundamental. And the question is, what changes does Aristotle make on Plato's view, and do his changes make it make more sense? That is a view which we're going to come to. Before I do, however, I'm going to come to one last big topic in Plato, and then we will have had a good overview of Plato's philosophy. So that is where I leave this. I hope if I have given you nothing else, it's a sense of wonder that Plato came up with this view, mistaken though it may be in details. It's quite remarkable that this was done 400 years BC. I think it's a subject that one should just contemplate in awe for a little bit and to see what he did with it. It's quite astonishing. How much he took from the Pythagoreans, well, that's a subject which we're going to come to. Okay, thank you. See you next week, please. subscribe, like. I'm sorry for those who are disappointed. In discussing the Timaeus, there are many people who will want me to have discussed, even if briefly, the subject of Atlantis, which is really discussed there and in the Crito. It's where the whole idea of the Atlantis comes from. I'm sorry I haven't done that. It's probably not really worth doing. It's certainly not interesting philosophy. Even if people find it fascinating, it is fascinating, if at all, for other reasons, I think. So that's enough said about that.